Here in example 2, we're going to use properties of exponents to rewrite radicals. The question, or the main question, how can you extend the properties of exponents to derive the properties of radicals? In part A, we're asked how can you rewrite the nth root of AB using the properties of exponents. So let's rewrite this a little bit more clearly. So we have the nth root of AB. And our first step is we want to rewrite this radical as a rational exponent, or with a rational exponent. So this would become AB to the 1/2 power, not 1/2, to the 1 over n power. And hopefully you remember that from last section, but this index here, so this index will be rewritten as the denominator with the rational exponent. All right, and then from here, using our properties, our power of product property, this 1 over n applies to both the a and the b. So we can rewrite this as a to the 1n and b to the 1nth power. And then they're asking us to look at some properties, but we do want to rewrite this in radical form. So it does seem a little counterintuitive. All right, why are we kind of working backwards? But here we're just looking to derive the properties of radicals in this case. So the a to the 1 over n is going to be rewritten as the nth root of a, and the b will be the nth root of b. All right, and those are being multiplied. So this is kind of, what we're looking for right here. All you're really going to learn from this, or what we're looking to learn from this, and we'll apply it in part B and further problems, is we want to say that this index applies to both of the terms inside, and we're allowed to split them up. And you'll see why that becomes pretty useful in part B. So part B, how can you rewrite the third root of 16x to the 5th using the properties of exponents? So we want to kind of apply, what we're just looking to do here, and the idea that we can take this index and split it up into two separate radicals. We just have to be careful and make sure that we're, basically following the rules. So I'm going to rewrite this first. We have the third root of 16x to the 5th. And the first thing we want to look at is we want to find factors of 16 and factors of x to the 5th that are perfect cubes. All right, so perfect cubes are things, where you have like one's not very useful, but 2 cubed. So we have 1 cubed is 1, 2 cubed is 8, 3 cubed would be 27. My screen's not cooperating with me over here. So 3 cubed would be 27, 4 cubed would be 64, 5 cubed is 125. So ideas like that. We're looking for these type of numbers. So we're looking for factors of 16. And a factor of 16 that's a perfect cube would be 8. So we have 8, and I'm going to leave a little bit of space, and that would be 8 times 2. Now, x to the 5th, what's a factor of x to the 5th that is a perfect cube? Well, x to the 5th can be rewritten in a couple different ways. So x to the 5th is the same as x to the 1st times x to the 4th, or x squared times x cubed, or you can kind of reverse that, right? You can do like x cubed times x squared and x to the 4th times x to the 1st, although these are the same and these are the same. So all of these are equal to x to the 5th, and I can rewrite that in any of those forms. So since I'm looking for perfect cubes, x cubed is a perfect cube. So what we're going to do is we're going to rewrite that x to the 5th as x cubed and x squared. Right? So we're allowed to do that. We can just break those up. Right? We've done problems like this before. And now if we go back up here where we separated them, that's what we're going to do. So you're going to take the cube root of 8x cubed times the cube root of 2x squared. And the whole purpose of this was to be able to take parts of the insides and bring them outside of the radical. So the cube root of 8 we know is 2, and we mark that over here. And then we know the cube root of x cubed is just x. And then we can bring the cube root of 2x squared along with us, and this would be our final answer. All right, this is our, I think I mentioned it earlier, but a reduced radical form. I think I mentioned it in the last video. So what you're trying to do is you're always going to try and break numbers up and, kind of take things outside. You may remember this, you kind of in the past might have done things like where you had radical 50 and you changed that to radical 25 and radical 2, which became 5 radical 2. It's the same concept. We're looking to do the same thing, and hopefully you understand this already and you can apply that to problems that might be a little bit more in depth. So that's it for that one. Just follow the properties. Use this as an example. Part A, remember, that was just for us to derive the property of radicals. Part B was what you'll be doing a little bit more. You'll actually see that in the practice.